Good morning, students. So welcome back after the long vacations of Diwali. I hope you have enjoyed the Diwali vacations. And today we are going to begin with the new topic, that is comparing quantities. Now the word comparing, we are very well acquainted with it. It begins from our home itself. Now comparing can be of qualities as well as quantities. For example, when I tell about qualities, in your home it may be, your mother may be saying, see your brother, how he is studying, and see you. So qualities are compared. Or see your brother, how he is good in drawing, and see your drawing. You are messing up with it. Qualities. But here we are not related to the qualities, we are going to study comparing quantities. Again, it begins from our house. Yes, it begins. How? See, keep this in mind. Your brother has scored 95%. You too should score above 90%. Oh my God, tensions. And then you start panicking, right? Because there is a sort of tension. My dada has got 95, so I have to score at least 90%. So comparison begins there itself in our house. So we are very well acquainted with comparing quantities. Now comparison can be made in various ways. First, subtraction. How? See here. Now within a few days I'll be displaying the marks of maths, and so you may compare now. Sajiri got 10 marks more than me. So what you did? You subtracted. Suppose you got 20 marks and Sajiri has got 30 marks. So 30 minus 20. So 10. Right? So Sajiri got 10 marks more than me. Comparison, but here we have used the method of subtraction. Another is ratio. That is dividing one quantity by the other. Right? So there also, for example, if height of Aryan is 200 centimeter and height of Vishnu is 100 centimeter. So what is the comparison you can do? We can say that height of Aryan is twice that of Vishnu. It is 2 times, exactly 2 times. Or we can say it in these words also, height of Vishnu is half that of Aryan. Right? So what we did here, we divided one quantity by the other. So division. Right? And the third comparison is by percentage, finding out the percentage. That's what I gave the example. Right? So first we'll study of ratios, comparing quantities by ratios. So in ratios, what we do? We divide one quantity by the other. Okay, for example, suppose Anita has 20 notebooks. While Ragini has 30 notebooks. Right? So who has more? Definitely Ragini. So how you can compare it? So ratio. How you can take the ratio? 30 upon 20. That is, so 10 3s are 30, 10 2s are 20. So 3 upon 2. Now you know how to write ratio. How we write? Yes. 3:2. This symbol is called as is to. 3:2. So how we read or how we express this? Ragini has 3:2 times notebooks that of Anita. Right? Or I can say it in inverse way also. Anita has 2/3 parts notebooks to that of Ragini. Now, why I have said here parts and first I have said times. See here, Ragini has more notebooks. So it goes on multiples. Right? So at that time we say times when it is more. And when it is smaller, Anita has lesser notebooks as compared to that of Ragini. So if I am finding that ratio, means Anita to Ragini, ratio of Anita to Ragini. So how it will be? 2:3. So 2/3. So we say that Anita has 2/3 parts of the notebooks as compared to that of Ragini. Do you understand? Okay, so one more thing. 30 notebooks, 20 notebooks. Notebooks will get cancelled. So do ratio has got any unit? No. Ratio does not have any unit. Okay, let us take some more examples. Right. Now, we use this comparison in our day-to-day life when we are comparing the speeds, when we are comparing the heights, when we are comparing marks. Yes, when we are comparing our performance in the exams, we use these comparisons. We use these ratios. Okay. Now, so, for example, as I have said, height of Aryan, suppose here it is 3 meters. Okay, and height of Ayush is 2 meters. So what is the ratio of heights of Aryan to Ayush? So what you will do? Ratio. And how you have to compare? Aryan to Ayush. Right? So 3/2. So 3 meter upon 2 meter. So you can see mm, that is meter will get cancelled and you will get 3/2, that is 3:2. Okay? Now, let me take another example. Speed of Gayatri's bicycle. Speed of Gayatri's bicycle is 5 kilometers per hour. Okay? While speed of Soumya's bicycle is 15 kilometers per hour. So if I ask, what is the ratio of speed of Soumya's bicycle to Gayatri's bicycle? So what you will do? You will divide speed of Soumya's bicycle by speed of Gayatri's bicycle. Right. Okay. So therefore ratio will be equal to the ratio. So 15 kilometers per hour upon 5 kilometers per hour. Right? So 5 ones are 5, 5 threes are 15, and kilometers per hour will get cancelled, and you will get 3 upon 1, that is 3:1. In other words, I can say speed of Soumya's bicycle is 3 times that of Gayatri. If I invert it, this comparison we have studied in 6th standard. I can inverse this. Speed of Gayatri's bicycle is 1/3 of Soumya's bicycle. I can say this. Both are correct. Both are correct. No doubt about it. Okay. Now, let me take another example. Okay. Now, this was related to the speed. Suppose if I come to marbles. Aditi has 18 marbles. Okay? While Rudra has 12 marbles. How many? 12. Now, let us find out the ratio of marbles with Aditi to the marbles with Rudra. Okay? So, ratio 18 marbles upon 12 marbles. Now, these come in the table of, yes, I know the tables, absolutely right, table of 6. 6 3s are 18, 6 2s are 12, so 3 upon 2, that is 3:2. Do you find here something? Here I have compared heights, and here I have compared ratio of marbles. Both are different properties, both are different quantities. But you have got same ratio. Can be. You can have similar ratios for comparisons of different properties. Okay? And one more thing. Ratios do not have any unit. Keep this in mind. Ratios do not have any unit. A ratio does not have unit. Do you understand? Now, let us move further to equivalent ratios. Okay, before coming to equivalent ratios, I would like to tell you one thing. When you are comparing the two quantities, ratio, they should be in the same unit. That is most important. See, I'll explain. For example, weight of a bag equals to 10 kgs. Okay? And weight of books equals to 2000 grams. Find the ratio of weight of bag to weight of books. Now here, if you see, this is in kg and here it is in grams. So if I want to find the ratio, they should be in the same unit. So either convert kilograms to grams or convert grams to kilograms. Which is easy? Yes, absolutely. Conversion of kilograms to grams. And I know. What I know? 1 kilogram is equal to, oh yes, 1000 grams. So what I will do? 10 into 1000. So that is how much? Exactly 10,000 grams. Now see whether the units are same. Yes, they are. So now we can find the ratio. Ratio of what? Weight of a bag upon weight of books. Right? Now, what is the weight of bag? 10,000. Okay? Upon 2,000. So 1, 2, 3, 1, 2, 3. 2 ones are, 2 fives are. So 5 upon 1. So that is 5:1. So weight of the bag to weight of the books, that ratio is 5:1. So always be careful while comparing quantities. See that both the quantities, they are in the same unit. If they are not so, try to convert them. And comparison can be done with same property. For example, if I am comparing lengths are to be taken, considered. If I am comparing weights are to be considered. I cannot compare weight with speed. I cannot compare mass or weight with height, that is length. Okay, because their units are different. Mass, grams or kilograms, and height, meters, centimeters. Okay, and so it becomes different, and so we cannot find ratios of them. So properties, they should have same units, and secondly, similar properties are to be compared. Okay, now let's move further to equivalent ratios. We can compare two different ratios and we can find out whether they are equivalent or not. If the two different ratios are equal, then we say that the two ratios are equivalent ratios. Now how to do that? So first what we do, we write the ratios in the form of a fraction. Then what we do, we convert them in like fractions. You know like fractions. Okay, and then once we convert them in like fractions, we compare them and we decide whether they are equal or smaller or bigger. If they are equal, then we say that they are equivalent ratios. For example, compare 2/3 and 5/2. Okay. So here, now 2/3 means 2:3. This is always already I have written it in denominator form, fraction form. Okay, and this also I have written already in fractional form. Okay, now here 2/3. So first convert it into like fractions. Now here 3 and 2. So what I will do, I will multiply 2/3 by 2. And I will multiply 5/2 by 3. Okay, so what we are doing, we are equalizing the, yes, absolutely, denominators. So 2 into 2 upon 3 into 2. So what I get? 4/6. Okay, am I right? Now 5/2, what do you do? Multiply 5/2 by 3. So 5 3s are 15 and 2 3s are 6. Do you get it? Now what do you get? 4/6. Now these are like fractions. Are they like fractions? Yes, they are. Why? Denominators are same. So they are like fractions. Okay, so 4/6 is smaller than 15/6. Can I say that? Yes. How I can? From the numerators. When the denominators are same, I can easily judge the numerators. Now 4 is smaller than 15. Yes or no? Yes. So what I can write? 4 upon 6 is smaller than 15 upon 6. Therefore, 2 upon 3 is smaller than 5 upon 2. So are they equivalent ratios? No. So therefore, 2 upon 3, that is 2 is to 3, and 5 is to 2 are not equivalent ratios. Okay. Suppose if I would have got here equal, then I would have said that they are equivalent ratios. In 6th standard, we have studied if two ratios are equivalent, then they are said to be in proportion. If two ratios, they are equivalent, then they are said to be in proportion. We'll come to that. Okay. For example, I will take one more example here. Right? Let us see. Compare 5 upon 2 and 10 upon 4. Okay. Now see here. 10 upon 4, if I reduce it, I'll get this. 2 is a multiple of 4. So no need to cross multiply. I can either multiply this fraction by 2. See here. 5 upon 2, I can write it as 5 into 2 upon 2 into 2. So what I get? 10 upon 4. Am I right? Yes. And 10 upon 4, I can write it as it is. No need to change. Now, are they equal? Yes, they are. Okay. So, 10 upon 4 equals to 10 upon 4. In reduced form, you will get it as 5 upon 2 equals to 5 upon 2. So, are they equivalent? Yes, they are. They are equivalent ratios, and so they are said to be in proportion. They are said to be in proportion. Okay. So, now let's move further. So, next part is keeping things in proportion and getting solutions. Suppose if I tell you, draw a picture of your house and your friend standing in front of your house. So Aryan Madhav had drawn the picture, right? So what he did? So he has drawn a picture of a house, his house, okay, like this. Okay? So this is window, door, and here it is the window, okay, and this is the roof of his house. And there is a boy or his friend who is standing in front of his house. And so what he did? He drew it like this. Now, is it correct? क्या हो गया? So first question, is this figure or the diagram Aryan has drawn, is it right? What do you say? Arey Aryan, how this is possible that your friend is bigger than the house? Am I right? So that is the first mistake. So what he did, he didn't took into consideration proportion, right? actually. Can our height be more than the height of the house? Not at all. So what he would have done, he should have done like this. He should have taken actual height of house divided by actual height of boy or his friend. That is equal to height of house in drawing upon height of boy in drawing. If you would have done that, then you would have got this figure right. If he does this, what is this? Proportion. So, when he follows proportion, then his figure will be, might be, in this way. See here. Right? So now it is correct, appropriate. So he has taken into consideration proportion, and that is most important. In our day-to-day life we use it. Where we use it? One example I can give. Maps. हमने इंडिया का मैप देखा है. आपने देखा है? Yes. Have you seen it? So they are in proportion with actual area of India, right? And that is taken into consideration, and then maps are drawn. So they are into proportion, they are in proportion. Then I can take another example. Flags. Do you know Indian flags? Yes, the tricolor. The length and breadth, they are always in proportion. The length to breadth ratio is 1.5 is to 1. Some countries they follow it like this also, 1.7 is to 1. You can convert this roughly. Instead of decimal point, I can take it as 3 is to 2. What I did, I multiplied this both by 2. 1.5 into 2, 3.0. So 3. And 1 into 2, 2. So 3 is to 2. So all the flags, they are in this ratio, length to breadth ratio, 3 is to 2. Okay, so they are always in proportion, they have to be. Okay, then Indian postcards. Do you know Indian postcards? Yes, now they have just vanished because their utilization has been decreased now. Then to some of the peoples they use it. Go and collect various kinds of postcards, find their length, find their breadth. You will always find them in this ratio, 3 is to 2. So day-to-day life example. Try to find out such situations where this ratio is followed. Such types of proportions, they are followed. Okay, so dear students, we'll stop here today and we'll continue in the next period. We'll see how to solve examples based on using this proportion, okay, and unitary method. So just revise what is unitary method, okay, and so we'll meet in the next period. Till then, have a nice day. Goodbye. Thank you.